All right. And so kind of jumping off this work that we just did in the previous video, we're asked to find 4 parameterizations of the unit circle. Okay. So we've done a couple, right? Ta-da, here's one. X equals cos of t, y equals sine of t, and the interval is from 0 to 2 pi. So 1, x equals cos of t, y equals sine of t, and our interval is going from, not t equals, t is in the interval from 0 to 2 pi. Okay, this is our function, right? Y is equal to g. These are our parametric curves, okay? And, you can think this, we start here and we rotate around. T is equal to 0. Here t is equal to pi over 2. This is negative 1, 1, 1. Okay? This is how cosine and sine are defined. And so it may seem a little bit like things kind of dropping out of the air, like, look, ta-da, it works. And yeah, I can see, absolutely. But this is also how our cosine and our sine functions are absolutely defined. And so like we're going to use this and we're going to leverage this into other ways of looking at parametric equations as well, other parameterizations of other curves, okay? And we have a second one. What did we do before? We did x is equal to sine 2t, y is equal to cos of 2t. If we wanted to trace our interval around only once, well, we just wouldn't go as far, right? Because we did 2 revolutions, we'd only need to do 1 revolution, so we'd only go from 0 to pi. Okay? And so that would be, we're starting here, and we're going in the, we're going in our clockwise direction, like this, okay? So this is t is equal to 0, okay? You can check these things, right? You could check these things. You're using sine 2t squared plus cos 2t squared. That's still equal to 1, okay? Other ones, there's many parameterizations of an individual curve because like the curve is the curve is the curve, but we can trace it in a variety of ways, right? That's why I'm trying to show you 4 different parameterizations. Let's do x is equal to, let's just throw a negative in front. Okay. Let's trace t going from 0 to 2 pi. Okay. What does this look like? Well, it's our unit circle, but where do we start? Well, cos of 0 is 0, negative of that. We're starting here, all right? T is equal to 0. And we're still proceeding in our counterclockwise direction, okay? This is the point t is equal to pi over 2, okay? Again, you can check negative cos of t all squared plus negative sine of t all squared is equal to 1 because this just becomes, like our negatives go away. Cos squared t plus sine squared t is equal to 1. Okay, let's do one more because there's so many ways of tracing this unit circle. Let's just do x is equal to sine of t, y is equal to cos of t, and make t go from 0 to 2 pi. Okay. Again, we're doing sine squared t plus cos squared t is equal to 1, right? We're getting back to our identity. What does this look like? Well, you can draw your unit circle. We know that's what it is. When t is equal to 0, we are starting here, okay? T is equal to 0, and we're moving in this direction 1 revolution around, okay? So this is t is equal to pi over 2, okay? Really urge you, I really recommend using tables and drawing pictures, drawing diagrams. Okay, so again, this curve, if we remove the arrows, if we remove the parameterization, we've got the unit circle, right? It's the unit circle, it's the unit circle, it's the unit circle. But when we add this time element into it, we can trace it around like this. We could start here, we can go around like this, we could start here and go around like this. We could go around 2 times, we could go around 20 times, okay? But we're still just tracing the exact same unit circle. If we remove that parameterization and just look at it, it's still the unit circle, okay? Many parameterizations, one curve, okay? Many parametric curves that describe the same curve. Sound okay? Let's leverage this idea of using cosine and sine to look at the ellipse. X squared over a squared plus y squared over b squared is equal to 1. So ellipses look something like this. This is an ellipse that is centered at the origin. It goes up to b and down to b, negative b, excuse me, starts at a and goes over to negative a. Okay? One parametric equation of this is x is equal to a cos of t, y is equal to b sine of t. Okay? I really recommend starting, especially when you're faced with x squared plus y squared equals 1 and some sort of variation on that with a constant in front, really recommend starting with cos and sine. Okay, we can do, well, let's figure out where this starts. Well, let's simply do a check. Let's do a check to start with, okay? Well, this becomes a cos of t all squared over a squared plus b sine of t all squared over b squared. Well, my a's are going to cancel, my a squareds are going to cancel, my b squareds are going to cancel, and I'm left with cos squared t plus sine squared t is equal to 1. Okay, and indeed, we're okay. Okay, so if I use my parametric equations, plug them in, I can back to my identity, which I know is the case. How do we actually trace this curve? Well, when t is equal to 0, right? When t is equal to 0, cos of 0 is 1. 1 times a is a. T is equal to 0. When t is equal to pi over 2, we get ourselves here. Okay? Cosine of pi over 2 is 0. Sine of pi over 2 is 1. 1 times b is b. And we rotate around once. Okay? And so our direction is counterclockwise, and we are doing 1 revolution. Okay? So t is going to go from 0 to 2 pi. Okay? I formally above described the movement using words. You're really welcome to kind of just put some arrows on here. If you're going around more than once, you can do a second second depiction like in this diagram. Okay, I'm going to erase that because I do not love it. All right, let's do something a little bit different. We're going to sketch the curve defined by this parametric equation. All right, so we have x is equal to sine t, y is equal to sine squared t, and our t is going from negative infinity to infinity. Okay, okay, we can do this. Let's notice something. Well, we can start with t, and we can do x, and we can do y. Okay. And we're going from negative infinity up to infinity. Let's go from maybe negative pi to maybe negative 2 pi to 2 pi. Okay, so we'll do negative 2 pi, negative pi over 2, 0, pi over 2, pi, 2 pi. This is just giving us an idea about how this thing works. And so sine of 2 pi, what is that? It's 0. Sine of 0 is 0. Sine of negative pi, that's negative 1. 0. Ooh, this one's 1. This is 0 again and 0. Okay, great. So I've got myself a 0. I square it. I got a 1, 0, 1, 0, 0. It's not really learning a lot here. But if we were to use like 3 pi over 2 or pi over 4, we might gain a little bit more information. But the other strategy we want to try is want to eliminate our parameter. Eliminate the parameter to get back to just x and y. Okay? So x is equal to sine t, y is equal to sine of t all squared, which is x squared. Okay? Great. I know what that looks like. Y equals x squared. That's my parabola. What's my issue? Is it possible for me to get everything? Can you get, let's say, for example, 416, right? That's part of the parameterization, right? Or that's part of that's on the general parabola, y equals x squared. What am I trying to write here? On this parameterized curve? Well, no. X is equal to sine of t, and 4 equals sine of t is impossible. Because negative 1, like sine oscillates between negative 1 and 1. Okay? And so in particular, and like then if you think about sine squared, so 0 is as okay, so this is our parabola. It is bouncing up and back and forth between the coordinate 1, 1 and negative 1, 1. Okay, and so at 0, 0, well, we're here, right? This is t equals 0. Okay, and then, well, what happens when we go pi over 2? We're gonna go up here. This is pi over 2, okay? But then we're swinging back for pi. This is t equals pi. And then, you know, when we keep going, we could also look back in time and we're just swinging up and swinging down, okay? Our particle oscillates on our parabola, y equals x squared, but between the coordinate, like between between x equals negative 1 and 1, okay? So our particle point oscillates on the parabola. Y equals x squared between negative 1 and 1. Okay? And so really what I'm trying to get at here is we are distinguishing very much between curves and parametric curves. Curves are just the set of points there. The parametric curves are those that are traced in a particular way. There's like an order to them, okay? And we can kind of like put interesting restrictions on them like this. And so it kind of like opens up this new world, which is really quite lovely. All right, let's pause here and we'll start again soon.